here we are going to start to sketch our very own situations. So an airplane flew from Melbourne to Sydney, Australia, and it's an 85-minute flight total. The plane, took 20 minutes to reach its cruising altitude, 15 minutes, and then 15 minutes to descend into Sydney. Sketch a graph that shows the plane's altitude during the flight. So it was an 85-minute flight total, 20 minutes to ascend or reach its cruising altitude, plus 15 minutes to descend and land. That gives us a total of 35 minutes, which means if we take 85 minus 35, we were at our cruising altitude for a total of 50 minutes. So here's our graph where each one is worth 5 minutes, each line along our x-axis. Our y-axis is labeled altitude. It did not say anything about the altitude. It's a relatively short flight, so it probably doesn't get too high in the air. But when we start sketching this graph, so here's a plane ascending into the air, took 20 minutes, and then we said it was 50 minutes at its cruising altitude. So I'm going to stop at the 70 because from 20 to 70 is 50 minutes. And then it takes 15 minutes to land or descend down like that. Now we could have, if other flights, maybe a plane could get higher in the air. So it still is in the air for 15 minutes at its cruising altitude, for 50 I should say. And then it lands, it takes 15 minutes to land. So graph should have this basic shape right here. And next, you have an empty bucket to collect rainwater. Rainwater falls for 6 hours. All right, so we have time. So here's 6 hours, then stops. After 5 hours, so 5 more hours, rain begins again and lasts for 1 more hour. This gives us a total of 12 hours. Sketch a graph to represent the volume of water in your bucket during this time. Label your axes. So, time is our x-axis, okay? Which means volume in the bucket is our y-axis. Now, it never talks about how much volume, so we don't necessarily need to label it. You could, if you wanted to, give your bucket a really big bucket, a really small bucket, but time has to be labeled. So there's 10 lines here along our x-axis, and we want a total of 12 in time. So we're going to count by twos. 2, 4, 6, 8, 10, 12, 14. We stop at 12, so I'm going to stop labeling. So it said it rains for 5 hours. 5 is between 4 and 6. Now, sometimes it rains really heavy. Sometimes it rains really light. So here's the point where grass could vary a little bit. I'm sorry, it rains for 6 hours. It stopped for 5 hours, so it rains for 6 hours right there. Stops for 5 hours. So 5 is halfway between, or for 5 hours, so that's a total of 11 so far. 11 is halfway between 10 and 12, so that's why I stopped at that halfway point. And then rains for 1 more hour. So that's what our graph should look like. Now, depending on how much it rained, let's say it rained really heavy for the first 6 hours. Obviously, it stopped raining, and then it rained really lightly for the last hour. See how it's the same basic shape, but it's depending on how much it's raining or not raining. So match each verbal description with its corresponding graph. You leave home, so that means we're starting at home, and we ride our bicycle to the library, so we're getting further away from home. We stay for a while doing research for a science report, then we ride to our friend's house. B says you ride your bicycle home from soccer practice. So we're away from home. The reason why I am saying we're home or away from home is because our y-axis, if you notice, is labeled distance from home. On the way, you stop at your friend's house for a while, and then you go straight home. So here, this first graph, right here, distance from home. This point down here, 0, 0, that means you are home. So if you're starting up here, that means you are away from home because your distance from home is getting larger. So this means you are away from home when you start. And then you start riding your bike home from soccer practice, and you stop at your friend's house, and then you ride home. So this one is going to be B, which obviously means this is A, but it says you leave home, so if you're leaving home, your distance from home is 0 because you're starting at home. Go to the library, stop for a while, and then you continue further along to your friend's house. Each graph describes the height of a candle over a certain period of time. Which graph is not a reasonable description for the situation? You light a candle and you let it burn until it burns out. Well, if we have a candle and we light it, okay, it stays at a certain height for a little while, right? And then the height slowly starts to go down, and it could pause and stay a little bit while the wax is building up and melts down. It could just slowly go straight down, but never is an actual candle that you light going to remain the same height, because notice, height is your y. Think about when you light an actual candle, the height of that candle decreases as it is lit. It will never ever stays the same. So this one, graph number 3, is not a reasonable description because candles lose height when they are lit. They will never remain the same.